Nick Marcouiller. He's the recipient of STEM Fellowship, and he'll be graduating this summer. He is also the president of Engineering Club. Today his presentation title is Auto Curtain. His mentor is Lisa Haley. So, Nick, the stage is yours.
All right, thank you. Well, I hope everyone's having a good day. Well, as you mentioned, my project is auto curtains. First, let me tell you more about myself. So, as you said, my name is Nick Marcouiller. I am a mechanical engineering major here at Brookdale. I am also the president of the engineering club. And going forward, I plan to receive my master's in mechanical engineering while also getting a degree in business. I will be graduating over this summer. I have a couple classes to take to receive my associates. Currently still waiting to hear back from schools to see where I'll actually be going, but I believe I have some good choices out there for me. So without any further ado, this is my project for the New Jersey Space Grant Fellowship, Auto Curtains. Gotta admit, if there was any presentation that was sort of important as this one. So the purpose. What I set out to do is create an automatic curtain system that would allow it to open and close the curtains at set times. I would be able to go in and set a time schedule to open the curtains about a half hour before my regular maybe alarm or radio or some other audio thing would go off to help assist waking up. This would allow for the morning light to come in and wake you up a little more naturally. But before I go into any more details about the project directly, first let me talk to you about the research a little bit. So falling asleep in a dark room is nice, but waking up in one is not. The fact is that most of us don't wake up like this. In fact, it's something more like that. The fact is that man was never meant to be woken up abruptly in darkness by loud buzzing, beeping, or siren-like noises. Rather, our ancestors woke up more gradually every day with the rising sun. The human body is designed to wake up during light sleep. Waking up during a deep sleep leaves you kind of groggy, tired, soreness, and never really recovered from the previous strains and stress of the previous day. This can be felt throughout the day as a sore, tired, not good feeling. And science has found that when people woke up during deep sleep, this affects their short-term memory, cognitive abilities, and even their counting skills. Just another reason that a math test in the morning is not a good idea. It's not meant by science. One of the consequences of waking up early or abruptly is a phenomenon called sleep inertia. The more severe the sleep inertia, the more abruptly we wake up, the more severe the sleep inertia. While we may feel that we wake up gradually enough in the morning, the fact is that it's a much longer process. When we do wake up naturally, as in on a relaxed weekend, morning is done by two main factors: the amount of external light and our circadian cycle, or internal clock. As seen by all effects, practicing going to sleep and waking up at unnatural times could be the most prevalent health risk in modern society. We need to remember that it's bad to sleep too little, but it's also bad, or even worse, to wake up in the dark. In the end, if we could just synchronize our sleep more closely with the natural sleep patterns, it could be far more easy to wake up. So why make it? Who will use this? So what I really set out to do is make a system that would be able to benefit from all the things I mentioned before, all the health benefits. So someone that wants to have a better mental health or get better sleep patterns, people that wake up early in the morning can easily benefit from using the morning sun as an assistant. People that travel a lot and want to help recover from jet lag a little easier, it's also a better way to get your head on straight of what time it actually is. But the real reason I made it was for myself, and because I need to escape the cave-like atmosphere that my blackout curtains have come to make. As you can see here, it is fairly dark in my room, even in the afternoon when the sun's shining through pretty brightly. And this makes it especially hard in the morning when there's even less light. It's pretty pitch dark. So they're definitely doing their job, just not in the morning. You might say, why don't I just get rid of the curtains? It seems like a very simple way to solve it. They're actually there because there's unnatural light that comes through the windows all night from floodlights or street light. So they are doing their job at the correct time, just not when I need them. So I also want to be able to benefit from all the health factors that having waking up more naturally with natural light can give you. So prototyping board. So there are two main prototyping boards, the Raspberry Pi and the Arduino, which are very popular. Both of them use a USB kind of connection to able to upload your software and any programs that you might need. Some of them have Ethernet cables where you can connect them to the internet and have them do capabilities in that sort. Some are wearable, they come in different sizes. You can have bigger ones with a lot more connections. Some, I said, are wearable. You can have very small, and you can use electronic threads, feed them through, and attach different things on smaller devices. All of them are open source, meaning you can upload any software to them, make them do whatever you want in the program. And some are even open hardware, meaning you can have the schematics and with the knowledge tools and capability, redesign the entire board to do whatever you might choose. So the process, the first thing I needed to do is figure out really what I wanted this to do. I knew I needed a motor and a sort of system that would allow me to know when it was already open or closed. I needed an LCD with some buttons to input the menu for the times. Through my research, I was able to go through and pick the different parts that I decided I wanted to use. This was kind of challenging because the whole board and everything was all new to me. I also never did any programming with different components. After going through and picking the different components that I think I might need and to use, I drew up a wire diagram because I needed to see if the pieces that I picked would actually work all together, not all together, but also with the main board. The first board that I did choose to do a wire diagram for did happen to be one that had enough ports, so that was, cut down a little bit of the time. So right here you can see is my original wiring diagram that I drew up. I went into Word, I could copy different pictures off of the websites, pieces that I might choose to use, and drew up with some pen, and some things were done in a program. And it seemed to work, so I went forwards and I ordered different parts before even having anything in front of me. So that was a little challenging. Then I ordered the parts. So Arduino. I chose to stick with an Arduino for this project, Arduino Uno. To be more specific, it uses a C or C+ programming, which is pretty easy. It was something that I actually learned in the engineering programming class that you take here at Brookdale. It has different inputs. So right here, these are the different input pins, output pins, power, ground, the main chip. This is where the USB would plug into, and just a regular power supply when you didn't have it connected to the computer. So the stepper motor and the controller board, I chose to go to stepper motor. You can see it up in the top corner right there. I also have a timer belt pulley on the top right here. This is the timer belt. It's just a rubber belt with different teeth on it used for precision. And to have it actually connected to my main board, I needed a controller motor board. That's actually something during the trial and error phase, I ended up burning one out because I powered it incorrectly, so I had to buy a new one. So a DC stepper motor is a DC motor, just with more precise steps. It's one that is prized for its speed control and positioning, repeatable positioning control. Stepper motors can be found in all sorts of applications, ranging from 3D printers to CNC machines to clocks and in robotics. In my case, I was looking for the speed control and also the torque that I was able to give me. I needed something that would be able to move the heavy weight of the curtains. So the LCD and other hats. So they're called hats simply because they have pins that line up directly with the main board. So you can see here there's one hat directly on top of the main board, and another one that's currently not being used as a hat. So two hats I have are a breadboard hat. I was originally using a larger breadboard, which I'll explain a little later, and you'll see pictures of. I didn't need that much space, so I found a smaller one that worked really nice. I also mentioned before I needed an LCD with input buttons so that I can input the times for the menus each day, your momentary switches, and the screen. Early stages of wiring, I said I needed a larger board. Well, the smaller one came quite handy and was able to make me compact it a little smaller. So the real-time clock. Real-time clock is placed there on my board for this demonstration. The real-time clock is what it sounds like. It's a clock, so its main purpose is to just keep ticking away, keeping the time. It also has a cell battery here, just in case the main board lost power. It never loses the time, and I don't have to go in and reset it. This is the main thing that the program is going to refer to as to when to execute. So the analog joystick right there, this is something that most people are familiar with, as it's something that's found in a PlayStation or Xbox controller. It was giving me, decided to add it because I wanted a manual option to open and close the curtains. The analog joystick is more accurate and sensitive than just a regular directional joystick. The reason I wanted it was, again, the opening and close function. In, say, in the mid-afternoon when I needed my much-needed college nap. So the limit switches. I originally didn't think I needed a limit switch because I was just going to use the stepper motor's ability to do discrete steps. And I was going to measure, how many steps it took to go from all the way closed to all the way open, and I was going to have that in the program. Later on, when I did decide I wanted the manual open and close functionality, it was necessary because the program didn't know if it was already closed. So say the time hit and it would try to close and they're already closed. What could we hit? So ones that I chose to use are called reed switches. They work with two little metal plates that pretty much sit on top of each other, as you can see here. And when a magnet gets close enough, the two reed switches touch and it completes the circuit, telling the main board that the limit was reached. These are also found in security systems in your windows. Open and close the doors. That's the little pieces that are in those little plastic. And then there'll be a magnet on the top of the window, and when they come close, they're good. And when they detach, that's when your security system knows that it's been breached. So here are a couple pictures of my process. I had the soldering iron and a third hand set up here to help me do some soldering. At this point, I was working on the analog joystick, doing some precise soldering, so I used the magnifying glass. At this point, this is the larger breadboard I was initially using. It was way too large. I was using at this point to solder the different pins of the stepper motor controller board together. They work in a way, they help you out wiring because this is like a power and a grounds. They run horizontal, and then each one of these are all connected together. They do not go across this bar in the middle. At this point, I was working on the LCD screen. Over there is the blank board. Over here is when I was first soldering in the resistors and the momentary switches, and not the chip at that point. There's just the resistors and momentary switches done, and over here is where I was able to get the LCD screen attached. So at this point, I had the stepper motor, the limit switches, and the joystick working together. As you can see, that's when I was also using the giant breadboard. I only had a couple connections because everything did need a ground and a power. So being that the board only had one or two different ground or power ports, I ran one power from the board to there, and then powered the entire strip that I needed, and I plugged them all in. So the whole system was working. I created the program where I can put the push the joystick to the left, and the motor would spin correctly, and the limit switch would all work. Next, after that, I decided to add the LCD screen. I needed that to input my menu, so I went ahead and got that working. I was playing around with the code. I needed to figure out how I was going to have the screen actually read out, the inputs Monday, Tuesday, Wednesday, or time. So I was playing around, and I decided, let's write a program that would say "Hello World." That's actually something that you first learn when you're learning how to program on the computer. That's what the computer first read out. So I decided that to be my first words to my LCD also. Next, I took the real-time clock and I tried incorporating its feedback to display on the LCD. On the left is the real-time clock reading directly out to the board, and over here is where I was able to go in through the program and get it out of military time and also display AM or PM, and I decided also to add the time. So the computer-aided design, or CAD as I'll be referring to, is parts that I drew up and designed, then went forwards and 3D printed out. On the left is a caliper, a system that I use to measure different things like the stepper motor and create the different parts to precise measurements. I was very familiar with the printer at that point, so I knew the tolerances of how to print it out. I knew, can I do this precise task? Did I need to make it a little bigger when it printed out? Over here is actually, I took one of the pulleys and dropped it into the 3D printing software and put it in the view where you can see the support inside, which is the yellow hatching, and light blue, which is actually the support. So you can see when the motor was printing itself, it can't print in the midair, so it had to add these different supports lines to build on top of. Also, I didn't need this to be 100% full plastic. Not only would it have taken longer, but it also would have been heavier. So at that point, I think that's a 15% fill. So how did I actually go through and do this? If you're not familiar with CAD, it starts off originally in a 2D plane where I'm able to draw the different lines out that I'm going to be using, and then put the measurements in. At this point, this was in millimeters. For this specific design, I only had to draw like half of it. This is actually the axis right here about which I revolved the entire thing about, so you can kind of see it. This was this right here, and this was all the little slot where the belt would sit, and then it got revolved around into the 3D model. This is a part that I didn't end up using, but I do have right here. I can pass them around, the different parts. These are ones that I actually drew up to have on top of the some different 3D printed things. I drew this up to actually be the pulley belt that would sit on top. I even went as far to make a set screw for it because the motor has a little flat spot on it, so you can tighten the screw down so it doesn't spin. I didn't end up using it actually because it was kind of a risk I knew when I was drawing it up. The precision of the 3D printer and creating the teeth didn't line up perfectly with the belt, and it was slipping. This is a piece that I drew specifically just for this presentation. It was just a mount to hold the pulley. That's being passed around on the left. It was what I originally drew up for the stepper motor. It just slid right in. I also added the set screw holes. So this is the part that I actually decided to design up. It's kind of inspired by like a master link of a bike. So what it works as is it uses to connect the two ends of the timer belt together. I decided to use the timer belt's own teeth to grip it. So what happens is the belt goes through, goes around the loop, and grips back and locks on with its own teeth. Altogether, this was actually a fun part. I was very familiar with the 3D printing, and I like drawing things up, so it wasn't that hard, even though it did take quite a bit of time to draw and print out. Alright, so now I'm going to talk to you a little bit about the code that I drew up very briefly. I can't draw on it like that. That's no. What a vision test now. All right. So over here is where I initiated the different pins and told. Wait, wrong one. Sorry. Okay, here we go. Over here is where I initiated the different pins and told the main board where everything was connected, the different components. I go in and I also left some little notes for myself, like the higher speed that I put in right here, the more less responsive, but less torque I got. Also, there was sort of a little delay, so I put that in there. Down here is where I actually found out. I added that part later, where right there. That's where I had the motor plugged in for a while, and I was finding out that it was still being powered when it didn't need to be, and it was getting really hot. It was like pretty much staying locked when I didn't need it. So I went in, and this is actually saying how put all the different pins that the motor is connected to and put them to low. It's pretty much not getting much power, therefore it won't get nice and warm. Down here is where I tell it pretty much if the joystick is moved left. First, check to see if the appropriate limit switch is activated, and if it's not, then go ahead and spin the motor clockwise, and the opposite, if it's moved right, go ahead, check the limit switches, then go ahead and execute. So as I said, I was playing around with the LCD and the real-time clock, so I went in and made like that little clock system as I was showing before. We'll look at it later. So right here is where I decided to get it out of military time, and also where I well, I go. I don't know what's working. A little further, you would see where I put it, and I also have it say AM or PM. And a little further, you would see where I also tell it to display the date. Now it's working. All right. So some challenges I definitely ran into. Programming, I'm not a programmer, so that was challenging. Even though I did take the class, it's something I needed to re-spark, get my interest back into, and also learn how to do the programming for the different components, as that was something I never dealt with before. Getting all the parts again to work together, finding all this stuff and wiring it all together. I'm also not an electrical engineer, even though a lot of this was electrical work. And overall, learning a new program, a new platform, something I've never dealt with before, nothing else I learned in class, all out by myself, learning how to do. So that was an interesting task. So future plans that I have for this is to get the main interface, main menu kind of up and working. It's not currently working right now, and getting all the parts, again, condensed down into a smaller package. Right now this is not how it would be on the wall. And then after that's all done, getting the system all mounted up on my curtains, getting the timer belt to go back and forth. I would also have to make a different pulley to be on the opposite end of my curtains. And one challenge I might see doing that is the resistance between the curtain rods and the curtains themselves. It might be a little too much friction, so I might have to change the rod out. So actually, you know, before I go to thank you, let me show you the system real quick. So if I push the joystick left, it will go left, right, right. If the limit switch was activated, you can see it lights up, and let's see if it goes the right way. If I push it to the left, it won't go left, but it will go right. If I have this one activated, I can push it to the right, it won't go anywhere, but it still will go left. Well, okay. So I'd like to thank Lisa Haley. She was my project advisor. She's in the back. She was someone that I was able to go through for any of my engineering questions, but it was also a great help through my entire time here at Brookdale. Gitanjali Kundu, which is the advisor for the entire STEM fellowship. She was a great resource and someone that set up all the events and someone that had great advice through the entire process. The New Jersey Space Grant Consortium, which is the NASA sponsored program, which was able to give me the fellowship that I wanted. My parents, which are there and there, one sitting on the floor. and Adafruit, which is the open source hardware company where I was able to get all my parts. And they were a great resource, so I can able to get example codes, work with them. If I had any questions and got stumped, I was able to go on their forums. But overall, it was an interesting challenge, definitely. Now that I know the platform, it's something that I already have plans for further projects when this one's done. I already have parts sitting waiting for me. That's it. Thank you. So at this point, is there any questions? Anybody?
When the project
Yes.
coming out?
Did you ever think about making it photosensitive?
I do. I actually have components at home to read the different light and lux and also UV readings. It was something that I decided it would be easier just to have it open like a half hour before my regular alarm goes off. Say it was cloudy out and they didn't open or something. Even with the curtains, if it was still cloudy, we could get a little more light in, even if the light sensor wasn't activated. So yes, that was something I did think about. Anything else?
When the project is going to come out? Like,
The
we
whole
have
full
to-
project, I don't know when these finals are over, definitely. Anything else? Anybody still have the parts, the plastic pieces? Where are they? There's one back there. I don't know what to do now.
I guess the next person comes up. That's all.